This video is a quick review of factoring polynomials. If you remember back in class when we first learned how to multiply polynomials, and then when we started factoring, we were using things called algebra tiles. We treated polynomials in factoring like an area model. So first let's go over a review of what each of the pieces of algebra tiles mean so that when I'm drawing these you have an understanding. We treated the blue square had an x by x dimensions, so it had an area of x squared. Then we had either the green, which had a 1 by x, or the flip side, sorry I don't have red, so orange will be our flip side, represented a negative x, and the green represented positive x. And then we also had the little tiny squares. Again, one side, each side had dimensions of 1. And this had an area of 1, and this had an area of negative 1. So what we looked at when we were, say, multiplying polynomials, for instance, if I had 3x minus 2 times x plus 7, first what we did is we built what we wanted. So I put 3 x's across the top to represent our, let's do it this way, and then minus 2, so there's 3 x's, x, 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 and then minus 2. So that went across the top, and then down across the side I had 1x plus 7. Okay, so when we did this using the grid, we would multiply what was here by here to get 3x squared, and then the green bar, 1x by negative 2, should give me negative x's, 2 of them. Okay, and then down across here I'd have each of the positive x's by each of the 3 positive. So 3x times our 7 would give me 1, 2, 3, 4, 5, 6, 7, 8. So I should have 21 x's total. And then that leaves me with positive 7 times negative 2. And so that's going to give me a negative 14. I'm going to make them circles just for ease of drawing. Singles. So again, when we did the grid, it was 3x minus 2 times x plus 7, so that gave me 3x squared minus 2x plus 21x minus 14. And we can see that in the tiles. Got my 3x squared, my 21x's, my negative 2x's, and my negative 14. So when I combine all of what I have here in the drawing or down here in the grid, I get 3x squared plus 19 total x's when I take away 2 to cancel out with the 2 reds. So 2 greens cancels out with 2 reds. And then I have 14 red singles. So we did this for multiplying. We filled in the area. Okay. Now, if I want to factor, that means I want to have the filled in area, and I want to get back to what I used to multiply to get that filled in area. So let's start with a simpler one. Let's start with x squared plus 5x minus 14. Okay? When we were multiplying and when we built this, this was the hard part. Knowing how to combine or split apart my bars so that I have space for the number of singles that I want. So I need to work with these and somehow split amongst the squares something that adds up to a total of 5 green bars. So I'm going to start with my x squared, and I know I need space for 14 red singles. So that could be one row of 14 or 2 rows of 7. I'm going to start with 2 rows of 7. One, two, three, four, five, six, one more. Alright, so what this gives me space for then is, if I want it to be positive 5, I could do 1, 2, 3, 4, 5, 6, 7 green and 2 reds, or vice versa. So if I did 7 greens, and 2 reds, the 2 reds plus the 7 greens would give me 5 altogether. So it looks like I found it. So now I need to look at my dimensions for my area. I've got x, and these are -1. So I have -1 gives us -2. And down here I've got another x, and I've got 1, 2, 3, 4, 5, 6, 7. So my factored form is x plus 7 times x minus 2. So we've done all of this before. So then we said, okay, well, how can I move away from having to draw this every time to going like we did with the grid when multiplying? How can I just use this? So I need to determine what goes in these two boxes so that I can figure out what's on the outside that multiplied to get to it. So let's start with x squared minus 7x plus 12. All of these have the form ax squared plus bx plus c. Okay? If you've noticed yet, or maybe you haven't, when we are filling in our area, what we're looking for are two numbers that ultimately multiply to whatever our a times c value is, and then also add to our b value. So in this case, we would have 1 times 12, so I need two numbers that multiply to give me positive 12 and add to give me negative 7. So if I go through the multiples of 12, if I do 6 and 2, there's no way for me to make either 6 or 2, positive or negative, that would ever add together to give me negative 7. So that's out. I could do 12 and 1. Again, there's no way for me to add those together in any combination of positive or negative to get negative 7. I have 3 and 4. Well, hey, positive 3 times positive 4 gives me the 12, but they don't add to negative 7. They add to positive. So if I made both of these negative, they both multiply to positive 12, and they add to negative 7. These become the bars that are separated. So we, in our grid, put our x squared, our blue square, which would go in this top corner. The values I just came up with is the representation of the red bars that I would have on either side of the square, and then the c value of 12. So, in order to get these two spaces, I need to know what times what gives me x squared. Well, x times x. Okay, so then I have x times what gives me negative 3x. Negative 3. And x times what gives me negative 4x. And then negative 4 times 3 does give me 12. So my factored form is x minus 4 times x minus 3. Let's go slightly more challenging. Let's do 2x squared minus 5x minus 12. So if I want two numbers that multiply to my a times c, I need them to multiply to 2 times negative 12, which is negative 24, and adds to my b value, which is negative 5. So going through the multiples of negative 24 that also add to negative 5, if I did negative 8 and positive 3, that would work. Alright, so my ax squared is 2x squared, so I've got 2x squared here. My negative 8x and my 3x go here, and minus 12. Now, you could have put the negative 8x where the 3x and vice versa, that's okay. Where this gets a little harder is knowing how to split up the 2x. I know ultimately I need 2x and x for x squared, but the 2, the only way I can get 2 is doing 1 times 2. So the question is, do I put the 2 here, or do I put the 2 here? Okay, so how I know is by looking at what it needs to turn into. If I put the 2 on the left side, I have to do 2x times this space to give me 3. I can't multiply 2 by anything nice to get 3. So that's my clue that the 1x goes there and the 2 is going to go up on top. So I have x times 3 gives me 3x, and 2x times negative 4 gives me negative 8x. So my factored form is x minus 4 times 2x plus 3. This method still works if you have a value that is missing, either b or c. So let's look at 4x squared minus 9. I can treat this as 4x squared plus 0x minus 9. So I need two numbers that multiply to 4 times negative 9, which is negative 36, and adds to my b value, which is 0. So it multiplies to negative 36 and they add to 0. That's going to be negative 6 and positive 6. Let's make our box. 4x squared goes here, negative 9, and then I've got negative 6x and positive 6x. So I could split this up into either 2x times 2x or 4 times 1. If I use the 4 times 1, no matter which space I put the 4, it would be a yucky number to turn 4 into 6 or negative 6. So that's my clue to use 2x and 2x. So now I've got 2x times positive 3 gives me 6x, and 2x times negative 3 gives me negative 6x. So my factored form is 2x plus 3 times 2x minus 3. In the next part 2 of this video of factoring polynomials, we'll look at factoring polynomials that have a higher order than quadratic, but give these a try first and watch part 2.